we now learn how to find the formula for the nth term of a quadratic sequence. Now, to begin with, it's important to highlight something. Every single quadratic sequence there is has a formula that can be written like this. un equals to a times n squared plus b times n plus c. So it's this formula that we're going to learn how to find in this tutorial. And we're going to do so with a couple of examples. The first example is, let's say we're asked to find the formula for the nth term of the quadratic sequence whose first few terms are 6, 11, 18, 27, 38, 51, and so on. Now, the first thing we should always do as soon as we're given a sequence of numbers is to look into the differences between consecutive terms. Here's what I mean. I can see that from 6 to 11, we're adding 5. From 11 to 18, we're adding 7. From 18 to 27, we're adding 9. From 27 to 38, we're adding 11. And from 38 to 51, we're adding 13. What we notice right away is that these differences are never the same. They're always changing. And when that happens, it's worth looking into what we call the second differences. And the second differences are the differences between the differences. That would look like this. The difference from 5 to 7 is 2. The difference from 7 to 9 is plus 2 again. The difference from 9 to 11 is plus 2 again. And the difference from 11 to 13 is plus 2 again. Now here we can see that the second differences are always the same. We say that the second difference is constant. And when that happens, it means that we're dealing with a quadratic sequence. Since we're dealing with a quadratic sequence, it must have a formula looking like the one I'm highlighting right now. Now, to find this formula, what we really need to find are the values of a, b, and c. And for that, we need to know 3 equations, I want to say, off by heart. The first equation is 2a equals to the second difference. And that will always be the case. The second equation is 3a plus b must equal to the difference between the first 2 terms. So I'll just write u2 minus u1. That's the second term minus the first term. And the third equation will be a plus b plus c will always equal to the first term of the sequence. So that would be u1. Now, if you didn't know these already, you definitely want to make a note of these. These are true for any quadratic sequence. Now, for our quadratic sequence, the one we see here, this works as follows. 2a must equal to the second difference. So that's this value here, the first value I see on that third row of numbers. So I go ahead and say 2a equals to 2. The second equation, 3a plus b, has to equal to u2 minus u1. Well, all that is this number here, that 5. That's the first number on the second row of numbers. So I'll just write 5. And finally, the third equation, a plus b plus c, must equal to the first term of the sequence. And in this case, well, that's 6. So we go ahead and write 6 here. Those are our 3 equations. Now, before solving these, it's worth pointing something out. The right-hand side of each of these equations is always simply the first number of each of the rows in our 3 rows of numbers. Indeed, we have second difference, difference between first and second term, and first term of the sequence. Okay, now that we've seen that, let's go ahead and solve these. So I'll start in the lower left-hand corner, and I start with 2a equals to 2. Well, that leads us to a equals to 2 over 2, and that leads us to a equals to 1. Now that we have a, we move on to the second equation, which was 3a plus b equals to 5. But since we know that a is equal to 1, that turns into 3 times 1 plus b equals to 5. That's 3 plus b equals to 5, and therefore b is equal to 5 minus 3. So finally, b is equal to 2. And now that we have b, we move on to the third equation. That was a plus b plus c equals to 6. So a is equal to 1 and b equals to 2, so this becomes 1 plus 2 plus c equals to 6. That's 3 plus c equals to 6. So that means that c is equal to 6 minus 3, which leads us to c is equal to 3. So we now have all three coefficients, a, b, and c. All we have left to do now is to actually write this sequence's formula. And that would be un equals to a times n squared, so that's 1n squared, which we just write as n squared, plus b times n, so that would be 2n, plus c, which is 3. And we're done. That's this quadratic sequences formula. Now the good news is, what we've just seen here will always work with a quadratic sequence. As soon as we see that the second difference of a sequence is some constant non-zero number, then our three equations will work. Let's go ahead and look at a second example. Let's say we have to find the formula for the sequence 0, 6, 20, 42, 72, and so on. Well, once more, we start by looking at the differences between the terms as we go from left to right. So from 0 to 6, we're adding 6. From 6 to 20, we're adding 14. From 20 to 42, we're adding 22. And from 42 to 72, we're adding 30. Okay, we can see that these differences aren't always the same. Indeed, they keep on changing. So we look into the second differences. Those would be, from 6 to 14, we're adding 8. From 14 to 22, we're adding 8 again. And from 22 to 30, we're adding 8 again. Once more, we see that the second difference of this sequence is constant. It's always 8. That means that we're dealing with a quadratic sequence. It therefore has a formula looking like un equals to an squared plus bn plus c. And now to find the coefficients a, b, and c, we use our three equations. Remember, the first equation was 2a equals to the second difference. I'll just write second diff. The second was 3a plus b must equal to the difference between the second and first term. So that was u2 minus u1. And the third equation was a plus b plus c must equal to the first term. So that's u1. So for this particular sequence, we'll have 2a must equal to the second difference, which is right here, 8. So I write it, 2a equals to 8. The second equation, 3a plus b, must equal to the difference between the first two terms. And I can see that value right here. That's 6. And finally, a plus b plus c must equal to the value of the first term, which is 0. Now that we have our three equations, we solve them starting with the top one. So we have 2a equals to 8, which leads to a equals to 8 over 2. So finally, a is equal to 4. Now that we know a, we move on to the second equation, which is 3a plus b equals to 6. Since a is equal to 4, this is 3 times 4 plus b equals to 6. That's 12 plus b equals to 6. And so b equals to 6 minus 12. And finally, b is equal to negative 6. We now have b as well, so we move on to the third and final equation. That's a plus b plus c equals to 0. Now, we saw that a was 4, plus b, which is negative 6, plus c equals to 0. Now, 4 plus negative 6 is 4 minus 6, plus c equals to 0. And 4 minus 6, well, that's negative 2. So we have negative 2 plus c equals to 0. And finally, c must equal to 2. And we're done. All we need to do now is to actually write this sequences formula, and that would be un equals to 4n squared, so I've used the value of a, plus negative 6n, which is just minus 6n. That's our value of b, plus 2, which is the value of c. And we're done. And so that's how we can find the formula for the nth term of a quadratic sequence. There we go, everyone. I really hope that helped. And if it did, please hit like on this video and even subscribe. It really does help us. See you soon.